Welcome to the Real Python Podcast. This is episode 141. Have you used the Python REPL, read, eval, print loop, to explore the language and learn about how it operates? Would it help if it provided syntax highlighting, definitions, code completion, and behaved more like an IDE? This week on the show, Christopher Trudeau is here, bringing another batch of PyCoders Weekly articles and projects. We discuss the drop-in REPL replacement, bpython. bpython enhances the interactivity of a Python REPL session. It's also a powerful teaching tool for instructors and students to experiment with and explore Python code. Christopher shares a recent Python enhancement proposal about formalizing the grammar for f-strings. The PEP describes a reduction in the underlying parser code complexity and provides for future features like comments in multi-line f-strings. We share several other articles and projects from the Python community, including a news roundup, a collection of surveys to classify Python virtual environment workflows, a course about context managers and Python's with statement, a discussion about microfeatures we would like to see adopted in Python, a Python terminal music player, and an infinite array powered by AI. The InfluxDB time series platform empowers developers and organizations to build real-time IoT, analytics, and cloud applications with time-stamped data. Learn more and start for free at influxdata.com. All right, let's get started. The Real Python Podcast is a weekly conversation about using Python in the real world. My name is Christopher Bailey, your host. Each week, we feature interviews with experts in the community and discussions about the topics, articles, and courses found at realpython.com. After the podcast, join us and learn real-world Python skills with a community of experts at realpython.com. Hey, Christopher, welcome back.
Hey there.
So you found a few news items to kind of get us started here this week?
Yep. Just a few things, a couple releases. First, Pillow, the image library, has released version 9.4. It includes some new encoding features for both WebP and JPEG 2000 formats, some new EXIF data things if you're playing around with metadata and cameras, and a couple of security and bug fixes. Speaking of bug fixes, Django 4.1.5 is out, and it's got a crash fix for the array field. So if you happen to use that, that might be something to look at. And I'm not sure on the timing of this one. I came across a couple of announcements on Plone 6. There's no date stamp on the announcement, so I'm not sure how stale this news is. It might be a little older, but I keep seeing posts about it, and it's a major .0 release. So if you're into the Plone space, it's worth checking out. And finally, a quick shout out to PyCon Italy. By the time this segment goes to air, it'll be past their due date for a call for proposals, but the tickets are on sale, and the conference is May 25th through the 28th, and the topics are available. Some topics will be in Italian and some topics will be in English, so you don't have to speak Italian if you're interested in going.
Yeah, it's going to be a very busy spring. Lots of conferences coming up. Probably be talking about a lot of them, but also I'm hoping to attend a few. I'm trying to work that out to see what I can make happen, at least sort of North American ones at the moment. So that gets us into topics. And my first one is a real Python tutorial. And this one is from one of our core team members, Bartosz Jakinski. And it's about a tool called bpython, which I've used a lot. If anybody's watched my video courses, I've created for real Python over the last several years, especially anything that's not about the most recent ones, which are the Python basics. I was using it as a tool, and it's an interactive REPL replacement. The article is titled Discover bpython, a Python REPL with IDE-like features. There are other sort of alternative REPL tools, sort of REPL replacement tools that the REPL, if you're not familiar with it, is the read, evaluate, print loop that gives you a tool when you just type Python at a prompt or Python 3 at a prompt, and you get the triple greater than sign prompt there, and you can just start typing your Python code. That's considered the REPL sort of session. And so it's a great way for you to practice your Python skills or try things out and so forth. Again, other ones that are out there's one called IPython that's kind of from the Jupyter family of things. And PT Python is another one. The B in the name is from Bob Farrell, who was the original author and maintainer. Just a quick note, it is really much based around Unix sort of environments. There was a Windows sort of fork of it for a while, but it just doesn't seem to work well at all with Windows anymore as Windows keeps moving along. But a nice thing about the latest versions of Windows is there's the Linux subsystem for Windows, and you can get it installed there if you're using that subsystem for Linux on Windows. And there's information in the article about that, some links for you. But if you're on Mac OS and just standard Linux, you can just pip install it. And there's all those instructions. That's actually a portion of this article, kind of getting you going, installing, and working with it as an alternative. And why do I like it? It was actually something that Dan showed me in some of his early tutorials that he was doing online, video sort of stuff. And it definitely does the show part of teaching, where it automatically highlights your code the way like an IDE would. And to have that in a REPL session is really nice. That sort of syntax highlighting, indicating to the user that this thing that you're highlighting is potentially different from another. So things like operators, your comments that you're typing, variable names, and actual like function definitions, and even literal values like strings and numbers or Booleans, they're all highlighted differently and colored differently. And so it helps you kind of quickly be able to identify what's going on. And as a teacher, especially for beginner sort of stuff, it's really nice to see that. So along with the syntax highlighting and coloring, it has a lot of other really kind of nice features that kind of make it a bit like not having to switch from, you're working in something like an IDE. A lot of Python users are, unless they're using something remotely or logging in somewhere else and they're not getting some of those advantages. But things that people like about IDEs is they give you code completion, they give you highlighting of syntax and all these other kinds of nice features. But then you're like, oh, I want to go test something out, and you drop out into just standard Python prompt and you lose all of that. And this allows you to have a tool that as you drop back into just like a REPL session outside of the IDE, you're continuing in that same mode. You're not sort of context switching, which is something Bartosz brings up, which I think is a good point. I definitely like that about it. Again, another teaching feature that I really like about it is that it will show function signatures or doc strings as you're typing along. So along with the thing I mentioned earlier of autocomplete, as you type the beginning of a word, it'll show all the different options that you could have, and you can kind of tab through them. Or if you've typed far enough and there's no other choice, you can hit tab and it'll autocomplete. And this is really kind of nice to show students, or if you hit like dot and it'll show all the different particular methods that are available for something. It just really kind of opens up people's eyes of like, how is this working and what's happening with it, and being able to kind of explain stuff with that. And the function signatures and the doc strings even add more of that functionality without having to do a whole ton of extra stuff. It has sort of bracket matching features, again, highlighting there, along with all the other things of suggestions and completions. It automatically indents for you, which is nice. Again, very much like an IDE. It has a history. So like how you can maybe use the up arrow in a terminal session or normal REPL things to kind of repeat things. This one actually has sort of context to that. It can actually kind of remember multiple steps of something. And it actually has kind of a similar feature for that, for like rewinding back and forth multiple steps, kind of like a deeper undo, which is really neat. There's an actual file that gets saved that, again, as a teacher, I occasionally need to clear that thing out because it has quite a long memory, and it will try to autocomplete with other kinds of things or remember other steps. And often I want to clean that thing out to not have anything in it. But
do you know where does that file get stored? Is it like local to your project, or is it like a central dot file?
It's a central dot hidden file. Yeah. And I had to look for the name of it, but it's pretty handy for doing that again if you're using it as a way to teach. Just go, okay, I'll clear this out so it's not, because otherwise it'll like remember and show examples or suggestions of what you were trying to type before. And again, if you're trying to teach a concept, sometimes you want to keep that out of your viewer's mind that this is like happening for the first time. And so that's my reason for doing that. Along with the teaching features I mentioned, it has features for copying the clipboard, the entire contents of your whole session, which is really nice, or saving that out to a file. He dives really deep. Bartosz is kind of known for that. He's done, we've mentioned him multiple times on the show, but he likes to kind of dig into deeper things. In this case, he's diving deeper into the configuration of BPython. So not only like how it highlights things, he covers how to use it in a sort of debugging session with something like PDB. He then talks about some of the quirks of it. And then the very end of his article here, he dives into how to contribute to the project and what's kind of involved in there. So again, a nice deep dive into a tool that it's like a real nicety, one of these things that, again, I think it used to be the most common question I would get for one of my video tutorials when I was starting. They were like, what is that thing he's using that's highlighting all the code, and why doesn't mine look like that, and so forth. And so we would always have these like additional links and other stuff to sort of explain, well, yeah, that's BPython. It's this nice thing. So it was one of the most requested things as a tool that could maybe enhance you exploring and learning Python as you work. Do you use anything like this?
No, I still use the old vanilla REPL, and it's one of those things that every time I go to do something complicated in it, I'm like, oh yeah, I was going to go do some research on these because there's a bunch of them. There's competing sort of tools out there.
Yeah.
I was about, I don't know, 10 or 15 years ago, one of my developers set it up as default in one of our environments, and at the time, our machines weren't fast enough, and it didn't seem, I don't even remember which one it was, but it just didn't feel responsive enough to me, and it drove me nuts. So I was like, get rid of that. And
knock it off.
You can do whatever you want in your own environment, just don't make it the default. Don't make the rest of us use it. So I was always sort of a little hesitant about going back, and processors have caught up, and it's a much better situation now.
Sure.
It's been one of those things that I keep meaning to do, and I find particularly with the REPL, I often you'll write a little mini function and you'll test something, and you're like, oh, you'll break something in the middle of it'll be wrong, and you're like, okay, now I have to do up arrow 5 times, once for each one of the lines in that function.
Yeah.
But BPython deals with that kind of stuff a little better.
Yeah.
So it's on my to-do list. I'm looking forward to getting into this article in detail. And I think I heard, and I'm sure I may be wrong about this, but I thought I heard some more were coming about some of the alternatives as well. So it's something to look forward to.
I hope so. Yeah, that was going to be a thing, and it's something I've wanted to do on the show, is maybe talk about some of the alternatives. I think in the very first episode with Ger Arna, we talked about the one that he likes, which is IPython, and he's very much in the data science world, and I think that one is most popular there for bouncing things in and out of sort of like a REPL environment. It definitely feels like you're working in like a Jupyter thing with the little numbered squares as you're kind of typing through stuff.
Yeah, and a lot of these also have macro mechanisms as well. I think IPython calls them magic words, so that there's certain things you can do to common things. I think like the clipboard stuff you mentioned is handled through that kind of stuff as well. So
yeah, and the other one I've seen for the window users who were doing tutorials for us, they like the PTPython one, which is very similar. So
right,
stuff to check out. What's your first one?
I'm going to talk about a PEP, because who doesn't like talking about PEPs? This is 701, which is titled Syntactic Formalization of F-Strings. Someone has to teach our PEP writers how to write stuff that is meaningful to those of us who aren't parser grammar people. Bit of a mouthful. Anyways, so You'll remember that F-strings were introduced way back when in Python 3.6. That's PEP 498 for those of you who are curious. And the 498 covered a specification for F-strings, but didn't actually define a parsable grammar. And the idea behind this new PEP 701 is to create a grammar for the F-string format. And this would allow the newer parser that got introduced, I think it was in 3.9, to do the parsing of the F strings rather than a bunch of CPython code that does it in the background right now. And so, in addition to simplifying some code, this will also remove some of the current limitations on F strings that the old parser required. So, for example, at the moment, you can't put comments inside of an F string, even if they're multi-line ones, and you can't nest expressions. And feasibly, from a language perspective, there's no reason not to allow this. It's just the spec for F strings didn't allow it, and it would have made the little mini parser, more complicated. And so it even goes a bit deeper than that, though. So right now, how these are parsed is it's seen as a string. So it's a string token. And then a specialty step goes, it's a special kind of string token, and then passes it on to something else. And that sounds like, okay, who cares? But one of the consequences of this is, the new error messaging stuff that got added in Python 3.10 and 3.11,
Right.
it can't be used inside of the F string. They can't give you better hints because the outside parser and the inside parser are two different things.
You can't look inside of it.
And they'd have to write extra code, and essentially the primary parser can't. It just sees it as a string token.
Huh.
So by elevating the F strings out into their own kind of tokens in the parsers and having a grammar for this, all these challenges go away. Now, I don't know how quickly they will actually start adding some of the features, but by moving it to the grammar, it allows them to do that in the future. This PEP went through really, really quickly. It was created in November, and it's already slated for Python 3.12. So, we've talked a few times on the show about how we both love the new error messaging stuff. So I'm looking forward to being able to see these F strings augmenting with that kind of information. I think it's a big win. And, the other things like the comments and certain kinds of nested pieces, I'm indifferent. It's great if it's there. It'll make the F string more like Python, the language. But the error processing was the thing that made me smile.
Yeah, Pablo is definitely involved in it. He's the top name on the author for the 701. So being so involved in the error messages and kind of tying in. Nice. Are you building real-time applications? Check out InfluxDB, time series platform. InfluxDB is optimized for developer productivity, so developers can build IoT, analytics, and cloud applications quickly and at scale. With its data collectors and scripting languages, a common API across the entire platform, and highly performant time series engine and storage, InfluxDB makes it easy to build once and deploy across multiple products and environments, at the edge, on-prem, or in the cloud. Check it out and start for free at influxdata.com. That's INFLUXDATA.com. My next one is from a previous guest, Brett Cannon. He's been on a few different times, and if you don't remember Brett's sort of background, he's a core dev and a member of the Python Steering Council, but he also works for Microsoft. He works on the dev experience sort of side for VS Code and is involved in the Python extension for VS Code.
And you're forgetting the important part. He's Canadian, but go on.
Yeah, snarky Canadian, as his website says. He was on a while ago and had talked about a project he has called the Python Launcher for Unix. And he's been working on that for a while. I think I mentioned also that something I noticed about him was multiple years ago. I said, why do you like to do polls? And at the time he was doing most of that on Twitter, and now he is only on Mastodon. So he's been kind of repeating that sort of trend of like, I like to poll the followers. These are mostly sort of Python people following him. And he'll ask questions of them to think about decisions he's making as far as like software and so forth. And so the article on his blog is called Classifying Python Virtual Environment Workflows. He's got like a handful of different sort of questions he wanted to figure out. So it's all really diving deep into the sort of idea of how do people use this tool of virtual environments? And the article really focuses on sort of, I don't know what to call them, vanilla, sort of standard Python virtual environments, and not using the Conda environments, which is very, very popular in the data science world, but they often will use them very differently and they behave differently. So it's more focused on, I guess, more of the Python side. one first question was, okay, in your setup, who or what manages the virtual environments? And, could it be a tool that you're using, a tool like pipenv, which will automatically create the virtual environment, and then it also sort of decides the location of like where it's going to store it? There are tools like Poetry and a couple other ones that are tools that try to help with that experience also, and might do the same thing where there's like a central repository somewhere in your machine, maybe kind of obfuscated. It's kind of, hidden away so that you're not playing around in there, but it's going to manage that, kind of thing. There's a tool called Virtual Env Wrapper, or PyEnv Virtual Env. And these two are just sort of like assistants. They kind of maybe walk you through a script in the process of creating a virtual environment, but they don't hide or move the thing to a special location. They just sort of want other information and kind of walking through the process. And then the other way is to create it manually. You, the end user, is deciding as you type venv, Python -m venv, and then you're giving the virtual environment a name and potentially a location, but you are the one deciding where and what to call it. So I might ask you, survey you, Chris, as we go. Which of those are you typically using?
I still use virtualenv, and more out of habit than anything else. It was one of the superior ones when I got started, and
yeah.
And I haven't, the things that stuff like Poetry and the problems those solve aren't problems I've run into, because the Python I write isn't hundreds of thousands of lines of code. And so I'm usually able to manage the things without getting crazy.
Okay. So you're the one managing it usually with the tool.
So I'm usually the one managing it. And part of that is also, I don't really use an IDE, right? I'm old school. I use Vim. So I tend towards command line stuff in the first place because of that. The one thing that I do have that is sort of a modification is I do have a function defined in my bash script that is the act command.
Okay.
And my act command knows where I keep my virtual environments. So if I say act RP, it will go into the place where I keep my virtual environments and run the source on the directory called RP, goes into bin source and activates it. So essentially, I don't have to go into my virtual environment. I can activate them anywhere.
Yeah.
So that's the one sort of compromise I have to manage the fact that they're centrally located.
Yeah.
And one of the things he mentions in the article, which I think it's why I still sort of lean towards centralization, is there are a bunch of places where my virtual environment is not connected to my project.
Yeah, okay.
So like I have 2 or 3 different real Python virtual environments, and they've got all my teaching stuff in it, and they've got whatever library pieces I've been playing with recently. But I don't want to reset one of those up for every single course. So contrast that to, say, when I'm writing some code, I'll go create its own library. And so the idea of the VM being local makes me cranky from that perspective.
Yeah, because that's the next thing is like I have lived in multiple worlds with this concept. And maybe I'm kind of spoiling some of the later stuff, but the next question is really talking about like, where are the virtual environments kept? And I've kind of blended that a little bit. Is it a central directory? Maybe the tool did that for you, or potentially you're doing what you're talking about. Like you want to have a singular virtual environment for across sort of a swath of projects that you do, in this case, maybe the real Python teaching stuff that you do or what have you. Or are you doing it locally? It's like code like within the, for that particular project. And when I was working in an office, I was very often doing the thing with the central, like it was sort of tied to the install of Python that I had. And I would just keep adding, things to that based upon that install. And because I was doing the same kind of work again and again, and it sort of made sense that it was very script based and very kind of not project based per se for a lot of the work I was doing, is sort of cleaning and so forth. And so I guess that kind of makes sense. But when I moved to real Python, I was having to review other people's code or other projects. And it just made sense for each one of these projects as I was reviewing it to try to recreate what that person had. And so I end up building one every single time, which may seem like very slow, but it has worked for me, and that's kind of become my new trend, is to kind of just have it right there with the code, with a .venv sort of hidden folder with the virtual environment next to it. But it does, like you say, it does mean there's several steps for me to get going each time. And it's interesting. He then talks about how many virtual environments are needed. The idea of having a single version with the Python and everything is sort of centrally located. And 68% of the people that he surveyed said that's how they have it. And then he had multiple VMNs or virtual environments per, one maybe per the version of Python you have installed. So maybe there's a couple instances of Python on your machine, and that was like 18%. And then the other thing would be to do what I've been doing, which is like multiple environments for differing dependencies, and nothing really ties them together. And that was like a really small percentage of people. He is ignoring the idea that you might have additional virtual environments that get set up by tools, like testing tools like Nox or Tox. Some of these things kind of like sort of stand up their own environment to basically run the tests and so forth. But I was just intrigued by all of it. It's like he gets into like, why is he doing these surveys? And again, he is building these tools or working with these different tools that he would like the tool to find that virtual environment, and know that that's where this stuff is coming from, especially with something like an IDE that helps the code, be able to figure out like, okay, what is in here, what is installed, what is, ready to go, and kind of be able to do code completion, or potentially his Python launcher, he's sort of set it up so you can just type py instead of having to type out Python or Python 3 or whatever. And then it would know where it's sort of launching it from based upon these things. One question I have for you is naming conventions. Are you doing the hidden thing at all, the dot in front of your virtual environments, or is it not an issue?
Because they're centrally located, I don't need to care. So I don't bother. I have a directory creatively named pi_vr_ems, I think it is.
Okay.
And there are a whole bunch of virtual environments. Now, I usually put the name of the virtual environment in my prompt string, which is really common practice. So my virtual environments tend to be really short, obscure acronyms. So one of the things I've also started doing is I will often, inside of the virtual environment directory, put a soft link to the project.
Okay.
And inside of the project, I usually put a file which is .pyvrms, and inside of it, it just has the acronym, so that if I come back to a project like 3 years later, I'm like, okay, what environment goes with this?
Yeah, where does it go?
What is BQR? What was that for? I don't know what that is.
Okay.
And then you're talking about, he kind of skipped past the Tox stuff. But it's kind of funny because I end up in both places, because I have centralized virtual environments for my primary build, but I use Tox for my testing. So Tox has project-based virtual environments, and because I'm using Tox to test multiple versions, I end up with, technically, I've got virtual environments in the project and virtual environments outside of the project.
Yeah.
And the stuff outside is where I usually am doing my coding, and the stuff inside of Tox is really just the, hey, did I break anything in 3.7 kind of thing.
Yeah, just making sure that stuff works. Yeah, it's an interesting methodology. I like that he goes out to sort of, there's stuff that you do that you kind of sometimes will assume, based upon how you've been brought up and taught how to do this stuff and followed things, that you go, well, this is what people do. And it's like, well, maybe not.
Yeah.
And if
I've, not that it's quite connected, it's more connected to the packaging stuff, but I fought tooth and nail using the SRC directory. I don't know, it shouldn't exist. There's no need for it to exist. We don't need it. But now all the modern tools want it there. And I finally just gave up, and I'm like, fine, I will stop trying to figure out how to tell you where to put the code, and I will put it in SRC so you can find it automatically. So sometimes knowing what most people are doing and bending to that, Black is the same thing, right? I don't entirely like Black's formatting,
right?
But
aesthetically,
but everybody's using it, and it's one less argument to have. So sometimes being compliant with the majority makes it easier to code, even if it bristles against you a little bit.
Yeah, and if you're making a tool that needs to kind of make best guesses,
becomes that much more important.
Yeah, and so that's kind of the idea. So I thought about having to come on the show again. I'll see if I can reach out just to talk about that. And then he's been working kind of, we talked a lot about, he completed that series on his blog about the sort of syntactic sugar and the unraveling series that he did of like going through all the different pieces and kind of thinking about what is the core of Python. And part of that was to tie into, well, what's happened now with the WebAssembly. And now that that's kind of come to light with things like PyScript, they've also figured out a way to make that small enough to fit on something like MicroPython. And so he was on a recent like Talk Python episode talking about that. So I thought maybe that would be good to have him come back and discuss some of this. So we'll see. What's your next one?
So this is some real Python content, and we're going back to diving down the ego avenue here, and it's one of my courses.
Yes, it is.
It's on context managers, and it's based on the original article by Leodanis Ramos. I just like saying his name; it's fun. The course and the article are called "Context Managers and Python's With Statement." If you haven't played with them before, context managers are what you call the thing after a with statement. And if you haven't used the with statement before, the most common example is when you're opening a file. So you write with open brackets file name as handle, and all the code underneath that block has access to the open file through the named handle. So context managers are one of my favorite features of Python. Python is not my first programming language, and so I have spent a lot of time in other languages where I've had to make sure that my open file statements were matched with corresponding close file statements.
Yeah.
And bugs can happen and messiness ensues. Pretty much anytime you use any sort of resource, files, network connections, database connections, any of that kind of stuff, you end up with this pairing problem. The beauty of a context manager is that they automatically do the close thing for you so you don't have to remember. So it's cleaner code and automatic, kind of cleaner code that you don't have to think about, which is great. How a context manager works under the covers is there's an enter and exit method attached to them. And when you instantiate a context manager using a with statement, the enter method is called when the block is entered. And when the block is exited, either normally or due to an exception, then the exit method is called. In the case of that open file name thing I was using as an example, the enter method opens the file and the exit method closes it. So that's how they work. And like that guy with a hammer seeing everything being a nail, Python sees the whole world as an object. So it shouldn't surprise you that context managers are classes. Python comes with a bunch of them, but it really is just a protocol, and so you can write your own. That enter and exit method that I spoke about are both dunder methods, so that's double underscore enter, double underscore, and dunder exit. And any class with those two methods, if you get the signatures right, can be used as a context manager. So dunder enter can optionally return something. So when you call the with statement, whatever's returned by dunder enter is put in the as part. So back to that open, context manager's double enter is returning a file handle. So the file handle gets used in the as.
So that file is like ready to go and be used for the rest of your statement there.
Within this, inside of that block of the context manager. Yeah, that's right. And then the dunder exit method has a particular signature that you have to be careful with, but it takes 3 different arguments. I won't get into the details, but they're all for exception management. So it gives you full stack trace and, access to the exception object and all that kind of good stuff. So the course goes through different examples of context managers that are in the Python standard library, how to write a class-based context manager, and there's a decorator in ContextLib that allows you to build context managers out of functions using the yield keyword, so that shrinks the amount of code you have to write. So if you're not yet tired of hearing me drone on in your ears, then go check the course out.
Yeah, it's really nice because you kind of, the article and what you've covered here show how they're using it, if you will. The language is using it multiple times, and then you already mentioned it, but then how to build your own. So it's kind of nice to get that
you get a
contrast.
Yeah. And at risk of going all tangential here, I recently used this in one of my own open source libraries. So how when you write a unit test, how sometimes you want to, you have some data and you're looping over it inside of the unit test. And if it fails on, the 5th thing in the loop, you get the assertion error, but you don't really have the context. So then you have to add print or go into your debugger or whatever. So what I've done, I've got this collection of test utilities in a library called Whalestow. It's old English for the mistake they used to kill people on. Tells you how my opinion of a testing works. So how this works is this is a new context manager that wraps the assert raises context manager. So the idea is you give this manager a string that uses the syntax of the string format call, embedding whatever variables or info inside of it that you want. And if an exception is raised, this context manager catches it, formats the string that you gave it, passing in the local context, so any local variables that you have, takes that resulting error message, attaches it to the exception, and then re-raises the exception. So if you're running Python 3.11, that little error message is added to the exception using the add note feature. And if you're not, it squishes it into the error message. So you can add like variables from your loops or other things that are inside of the block that you would want to know when the assertion happens. And all of that will get attached to the error message. So yeah, enough about me and my code. Mr. Bailey, what do you think about me and my code?
I enjoyed this course. I got a lot about it, just kind of diving a little deeper than just like, the why and, what's going on there. And the creation of these things, I think, is what's really kind of the fun part. And it explores that whole special method, dunder stuff a little bit further. It's always been part of that whole magic stuff that you see inside of tutorials sometimes where you're scratching your head like, wait, what is going on here?
Yeah, we've got it marked as an intermediate. Like I wouldn't start out this if you're new to Python, use the magic, take advantage of the magic. But if you're ready to sort of progress to the next level and you're comfortable with the basic language features, this is a powerful tool.
This week, I want to shine a spotlight on another RealPython video course. Christopher shares this course earlier in the episode. It's titled Context Managers and Python's With Statement. It's based on a RealPython tutorial by previous guest Leodanis Pozo Ramos. And in the course, my co-host Christopher Trudeau takes you through how context managers work, what the Python With Statement is for, and how to use it to manage resources. What are common usages within Python's standard library? How to work with the special methods of enter and exit, and examples of how to implement your own context manager. If you've ever wondered what the with statement does at the front of a block of code, or how it operates, or how to implement it within your own code or classes, this course will be a valuable investment of your time. RealPython video courses are broken into easily consumable sections, and where needed, include code examples for the techniques shown. All lessons have a transcript, including closed captions. Check out the video course. You can find a link in the show notes, or you can find it using the enhanced search tool on realpython.com. So this next one, we had marked it kind of as like a bit of a discussion, but it sounds like you kind of did a little deeper of a dive, and I will add my commentary as we go, as I've been asking you questions.
My favorite kind of discussion, the one where I do all the talking. Yeah. So yeah, this is based on an article published by Hillel Wayne called Micro Features I'd Like to See in More Languages. So Hillel has outlined sort of 3 levels of features in programming languages. Level 1 is a feature that the language is designed around, and these can't usually be easily ported to another language. The example he uses here is Rust's borrow checker. Level 2 are features that are heavily define how the language is used, and that's like particular data types and how, say, async code works. And then level 3, which is what the article is actually about, is the fluffy stuff that pretty much any language could borrow. And the example he gives is actually a Python one, which is chained evaluators. So in Python, you can say if 2 is less than or equal to x, which is less than 10. You can do all of that in one statement instead of using an and.
Yeah.
And the language obviously has to support it, but there's no reason other languages couldn't build this in and steal the idea, right?
Do you feel like that last one, the quality of life feature, like kind of comparing the two, like 2 and 3, 2, he mentions like pattern matching being one of those things. And it was, I don't want to call it painful, but there's more work involved and changes to the language that kind of make it like a little harder to do. And then similarly, the quality of life might be something, like you said, that new PEP that kind of just traveled through really quickly for F strings. I don't know if that's quite the same. I'm guessing there might be other things there.
Yeah. But and again, the whole premise of the article is really just sort of these little things. And this guy must have some deep language experience or likes to play with it, because there's multiple languages in here where I'm like, I don't know what that is. Okay.
Yeah, totally. Yeah.
And the first feature he uses an example of this kind of thing is something that's in Python. And I remember being really happy when I discovered that this works. And in fact, I was just teaching a Python course a few weeks ago, and I showed the students this, and they went, "Oh, that's cool." So, and the idea here is, so if I say to you 1000000, and I may not have even done that right, you're going to go, what was that? Was that 100,000? Was that a million? Was that 10 million? And of course, when you see that in the code, you have the same problem. How many zeros are there?
As your eyes cross.
Exactly. And in Python, you can put underscores anywhere in the number. And the most common place to do it is to put them where North Americans put commas in those numbers so that it's easier to read, say, the thousands grouping. Now, that's actually cultural specific, and different people group them different ways, but it's essentially another tool to just make it easier to read these kinds of numbers. And this is one of the features that it's in a bunch of different languages. Python supports it. There's some variations on it for other kinds of numbers as well. And this was one of the things that he thinks should be stolen.
Yeah.
All right, so now let's move on to some things we might be able to argue about. The first one I kind of like. I don't think it'll ever happen, but I like it. So Lua supports multi-line strings using paired double square brackets. And the reasoning behind this is it makes nesting things easy, because the opening and closing tokens for the multi-line are different. So I can stick square brackets inside of it, and because they just need to match, the parser can just deal with it. And so there's a lot less escaping going on. And the only thing that you really have to escape is if you need an unpaired set of closing squared brackets inside of your closing square brackets. And that's
Pretty
really,
rare.
really uncommon.
Yeah, unlike quotation marks.
Exactly. Yeah. And, it's strings are one of those things that, Python's got both the single and the double quotes and the triple quotes, and it's helpful. But, it's one of those things where it's like, I saw this and I'm like, oh, yes, I want that. Please, someone in Python add this. Not in the article, but related. We've got a library in Python that does this, but I'd like there to be some way to either tell the string to do this, or otherwise I would love automatically removing the indentation, because I like my multi-line strings to be lined up like my code, but you can't do that because it's a string literal and you'll get all the padding. And there is a function to do that, and it'll remove it, but then you're making a function call when you shouldn't need a function call. So I've seen, I can't remember, might be Ruby. There's some language that you can actually put like a token in it, and basically you're indicating that please parser remove all the leading indentation off of this. So that's another one that I'd love to see get moved across while we're talking about strings.
Yeah.
Language I'd never heard of, Newlith, has a feature that I'm a little dubious about. It supports what's called function equals. So this is like, you think about the plus equals operator where you go x plus equals 1 to get x equals x plus 1.
Yeah.
You can replace the plus in this language with pretty much any function. So x max equals y is equivalent to x equals a call to the max function with x and y. I get it shortens it, and I just find this one hard to read personally.
That's brain-wise hard to parse.
Yeah, I think if you were used to infix notation languages where the spaces are more important, this might feel more natural. But to me, this one really all it does is save a few keystrokes. And I know I'm in the tiny minority amongst programmers that doesn't care about that, but I really, really don't care about that. I just type. It's not that hard. It's not the hard part of programming isn't typing. Get over yourself.
Right.
And nowadays the answer is the IDE does it for you anyways. And tomorrow ChatGPT will do it for you. So even less to do. Spoiler alert. We'll get to that later. Another one I hadn't come across, another language I hadn't come across before is Chapel. He pulls a couple different things from there. The first one, which I thought was interesting, is there is a way of declaring a variable called config. And the compiler automatically makes anything you declare as config available as a command line flag.
Huh.
So it's deeply integrating your argparse-like stuff.
Is ready to go for the CLI.
Yeah. I think it's neat, but I don't know how we could adapt it in Python because we've taken the library approach to command line argument management, and I don't know how these two ideas would fit together. Similarly, the Frink programming language supports dates as a built-in type. So it allows you to do hash year, month, date hash instead of like creating a date object. It cleans a whole bunch of code up. But again, we have this problem in Python that those are objects and they're in libraries, and I'm not sure how easily that stuff would interact.
Yeah.
And next one is a horrible, horrible idea, but that's fine. Hillel is a fan of kebab case in variable names.
Not a fan.
That's when you, yeah, I can't stand it myself. This is where, if you haven't seen these, this is where you use a hyphen, where Python programmers would use an underscore. So instead of first underscore name, you'd say first dash name. He argues that it's more readable, which I kind of get, and acknowledges this will never fly in most languages because the parser can't distinguish that from the minus operation.
Yeah, that's what Python's going to do right away.
Yeah, exactly. Both styles get used in HTML, and it drives me nuts because every time I go to write something, I'm like, which one of these is it supposed to be? And then, of course, the other thing is I have a whole PTSD experience with Lisp, which does support this. So it's also possible that that kind of turned me off. So
that's funny. It's called kebab case, and it's like the words have been skewered.
Yes, yeah. It's camel case, kebab case, and snake case, I think are the terms. It's somebody's getting creative. Well, just two quick ones. Ruby has a special data type called a symbol.
I like this one.
Denoted with a leading colon. And the most common use of this is inside of dictionary keys. And essentially, this allows the parser to be able to tell the difference between a dictionary key and a string. And essentially, it makes the parser's life easier and prevents certain kinds of bugs. There are other places where it can be used as well. And I think JavaScript is kind of trying to go down that way with the JSON keys not requiring the strings around it. So I think that's kind of related. I'm not sure how much difference it would make, but I think there are some edge cases that it makes more interesting. And the final one, which I like, is and definitely worth mulling over, somebody should go steal this, is the D language, which is, of course, one after C, supports unit test blocks on functions. So there's a syntax keyword for unit testing built into the language. So when you declare the function, you can also declare the unit test that goes with the function, which means the unit test isn't in the same file, isn't in a different file, excuse me. I love this. Anything that makes testing easier and more connected to the code is a really, really good idea in my book. So somebody go write a PEP.
Yeah, I mean, I kind of added my comments as I went, but I could see the advantage of that one. That sounds kind of cool. Like, again, not having to, have like these side files that have to be kind of connected to it. I can't think of any other like really strong ones. I think I've mentioned before, there's some uses I've seen of like the ellipsis to do like range kind of stuff and other kinds of like, again, sort of nicety kinds of stuff. But it's interesting. It is so cool to hear about all these other languages.
Yeah. There were a couple other ones buried in the article that were very sort of data science-y specific. He mentioned a use of an ellipsis.
Yeah, J is one.
But he mentioned the use of an ellipsis specifically to be able to do things like series.
Yeah.
Like mathematical series. And yeah, you mentioned the one with J, which I suspect is meant as an engineering thing because they've actually got a short form for powers that include pi, which is very common in certain kinds of mathematical transformations. So, yeah.
Yeah. Interesting. He's definitely a fan of surveying languages. It's kind of cool.
Yes. Yeah, without a doubt. I seem to remember coming across one of those advent of code mechanisms, and instead of it being a different program to write each day, it was basically like try to write the same kind of program in a different language.
Yeah. Okay. Yeah, that's a nice challenge.
It's an interesting little way of getting a survey. And I remember reading an article recently by somebody who'd gone through this, and his comment was kind of interesting. He said, it's not like he did this to go and find, I'm going to go change programming languages. But what he did by seeing the different approaches in the other programming languages, it kind of opened his mind up to different approaches inside of his primary languages, right?
Yeah.
You go and play with, Lisp or Haskell, you're going to get a lot more comfortable with some of the more functional concepts that are built into Python, and you might be more comfortable taking advantage of them, having seen, purely functional languages, right?
Yeah. And that moves us into projects, and I have the simplest of projects today. My project is from Misha Behersky, and it's called PyPod. And the idea is a audio player. In this case, when I got it to finally work after a little bit of wrangling with it, it mainly just plays WAV files. I think you could probably modify it or fork it and maybe get it to do MP3s or other types of stuff. But it uses Will McGugan's textual style in basically for creating a wave sort of PyPod player that works in the terminal. It has some nice, simple graphical interface stuff, the TUI, textual user interface kind of thing in it. I wasn't able to just simply pip install python-pod. I had to actually go ahead and brew install this thing called Port Audio, which worked. I'm not sure if it's only Mac and Linux. I didn't check that part. There's not a whole lot of documentation on this thing, but it was just fun. A fun little project that lets you play audio directly in the terminal. And it, in fact, will look at an entire directory of WAV files if you want, and it'll allow you to have a sort of a playlist kind of thing to play through them. I'm just intrigued by the project, and again, I like audio, so it was kind of a fun one to kind of dive into a little bit. It's something he's been working on pretty intensely. He's got a lot of commits in the last couple weeks here on this project. So, what do you got?
My project this week is, I think, wacky is the
Okay.
We'll start
we
with
like wacky here.
So this is by Ian Bicking, and if I'm reading his blog post correctly, it's based on an idea he saw on Twitter from Him Bodhisattva. And the idea is to make string or list classes that automatically use GPT-3 in the case of an index error. So Ian's posting starts with, some ideas are dumb enough you just have to try them. And in that spirit, he wrote Infinite AI Array. So the library declares two classes, an array and a dict. And the new classes overload the index error and key error exceptions, calling GPT using both the current data and the object context to predict, you hear my air quotes, the next item in the array or the dictionary. So, yep, bottomless arrays and bottomless dicts. You'll never see an index error ever again. Ian has a great sense of humor, and the README includes such statements as, but copy and pasting is too much work. How can I make my programs more dangerously unpredictable?
Yeah.
One of the examples he shows in the blog is a list of his favorite books. So Dune, Perdido, Street Station, and Red Mars. And he puts that in an array. And that array's got 3 items in it. And then he slices it for 8 items. And GPT goes, yeah, sure. And adds Hitchhiker's Guide, 1984, Lord of the Rings, Handmaid's Tale, and The Martian Chronicles. I have no idea. To me, that doesn't even seem related, but whatever, sure.
Right, exactly.
If this is not crazy enough, the library also has a class called Magic. And how you use Magic is by calling a function on Magic, whatever function, just name a function. It then uses the name and the arguments for the function to call GPT to make the function up. So
I see that there is like magic dot first Wikipedia paragraph.
Yeah. So it goes as far as it will prompt you to use a third-party library. So the example you're talking about, magic.fetch Wikipedia source, goes and says, hey, there's a pip install library for looking at Wikipedia. Do you want to install that? Oh, you need requests for this. Do you want to install that? And if you do, it'll pip install it and then go. And it uses both the name of the function, and if you give named parameters, it will also do that as well. So One of the examples he plays with is magic.primes called with an argument of 10, and it doesn't print out 10 primes. Whereas when you say magic.primes count equals 10, you get a few more items, but you still don't get 10. But magic.primes quantity equals 10 gives you 10 primes. All this is meant as a joke. Ian's very upfront about that, but it's a good joke and it's fun to play with. And he's got tools inside of the library so that you can see what, so example, if you go off and play with magic, you can then see what code got generated for magic. So you can even look at how GPT made the decisions that it did.
Wow.
So fun to play with. And if you want a quick intro on how to programmatically call GPT, then this is a small enough library that it's easy to digest as an example. So
Yeah.
it was, there's always fun stuff out there.
Yeah. Well, cool. Thanks again for bringing all that PyCoders goodness this week. And we'll see you in a couple weeks, Christopher.
Yep. Looking forward to it.
And don't forget, easy to start and scale, InfluxDB time series platform is available in the cloud, on premises, or locally. Get started for free today at influxdata.com. I want to thank Christopher Trudeau for coming on the show again this week. And I want to thank you for listening to the Real Python podcast. Make sure that you click that follow button in your podcast player. And if you see a subscribe button somewhere, remember that the Real Python podcast is free. If you like the show, please leave us a review. You can find show notes with links to all the topics we spoke about inside your podcast player or at realpython.com/podcast. And while you're there, you can leave us a question or a topic idea. I've been your host, Christopher Bailey, and I look forward to talking to you soon.